Okay, welcome back everybody. This quick video is meant to talk a little bit more about math and Java. There's no code here, it's just some notes. So if you want to put away BlueJ and get out some notes, and this PDF I'm referring to will also be up on Schoology. So the conversation right now, I want to talk a little bit about what happens when you mix ints and doubles. This is something we've talked a little bit about in class, but I want to just go into a little bit more detail. And the rule is relatively simple, and I wrote it right here. If an expression involves both an int and a double, the int gets converted, and I'm putting that kind of in quotes, sort of gets converted into a double for the purposes of that expression. So here I have some code, int num ponies equals 7. We have 7 ponies. And then double weight is 132.8. Weirdly, all of my ponies weigh exactly 132.8 pounds. So this first expression here is what I'm talking about. Double x equals num ponies times weight. So num ponies is an int, weight is a double. Notice this expression right here, we're mixing an int and a double, right? Num ponies is an int, weight is a double. So we have an expression involving both an int and a double. And what happens is this rule, the 7 that is num ponies, just sort of consider that to be a double, like 7.0. And then it does the math double times double, or 7.0 times 132.8, and that's the value x gets. So it's a pretty simple rule. If you have an expression involving an int and a double, just temporarily the int is considered to be a double, and you're all good. Did that again here. Double y equals 16.3, that's a double. 5 is an int. Oh no, I'm mixing a double with an int, but not a problem. This 5 just gets considered to be 5.0, and we're all good. Okay? Using that rule, if you want to convert between an int and a double, this is something you're going to want to do from every so often. You have an int and you want it to be double for some reason. You can just exploit that rule and cleverly multiply by 1.0. So here, if I say double z, I want some double, but I want it to be the value of num ponies. Well, look, I can cleverly just multiply by 1.0. 1.0 is a double, num ponies is an int. So according to that rule above, if you mix a double 1.0 times an int, it gets the num ponies becomes, this then turns into 7.0, and then you're fine. Z is just the value 7.0. It kind of converts this num ponies that was an int into a double. If you want to go the other way, you have to use typecasting, which we talked about a little while ago. So if you want to convert from a double into an int, this is where you must typecast. So weight is a double, A is an int. So I do this weird syntax where I put the word int before it, and then this turns this 132.8 into an int. And how does it do that? It basically ignores everything after the decimal point. So weight used to be 132.8, and then the value A would just be 132. It throws away the 0.8. It always kind of rounds down. Even if it was 132.999, A would end up being just 132. It ignores everything after the decimal point, or it rounds down. One more thing to talk about in the PDF on the second page is I want to talk a little bit about how some of the fundamental operations work: addition, subtraction, multiplication, division. And if you think about it, addition is all fine in the sense that if you add an int and an int, the result will be an int. If you add a double and a double, the result will be a double. Most of the operations, addition, subtraction, multiplication, division, all work like that, right? Multiplication certainly does. Int times int is going to be an int. Double times double is going to be a double. The one operation that doesn't work like that is actually integer division. And if you think about integer division, int divided by int will not always be an int. So let's talk a little bit about how integer division works. This is the one, there's nothing really special to talk about with addition, subtraction, and multiplication, but division's a little bit special. So the way it works is it actually throws away the remainder or the decimal, just like it did in the previous example. So 19 divided by 5, 19 is an int, 5 is an int. This would be 3.8, or it would be 3 4/5. But the way it works is it just throws away the remainder, or the decimal, or the last fraction. So A would end up being 3. Similarly here, 5 divided by 3, 5 is an int, 3 is an int. This ends up being 1 2/3, or 1.66666. we just throw away the 2/3 of the 0.666, and b would end up being just 1. So that's all pretty easy. It's a pretty simple rule. But sometimes actually you want the remainder. You want that part that you throw away. So I'm going to have to introduce a new symbol for you, which is this percent symbol here. The percent symbol is the mod operator. Mod is spelled M-O-D, and it's kind of short for modulus, which is a fancy Latin word for the remainder. So think about 19 divided by 5. Well, that's 3 4/5. Or you can think about it as it's 3 with a remainder of 4. So integer division gives you the 3 part, but the modulus or the mod operator gives you the remainder. So 19 mod 5 is 4, because when you divide 19 divided by 5, the remainder is 4. Okay? One other quick example, 5 mod 3. Again, that's 1 2/3. So the remainder is 2. So 5 mod 3 would end up being 2. We'll get a lot more practice with mod, but let's just talk about it a little bit more. How about 22 mod 7? Well, 22 mod 7 is 3 with a remainder, or 22 divided by 7 is 3 with a remainder of 1. So 22 mod 7 would end up being 1. How about 21 mod 7? Well, 7 goes into 21 evenly, so that's 3 with a remainder of 0. So 21 mod 7 would be 0. One little goofy one, 7 mod 8. Well, how many times does 8 go into 7? It's 0 with 7 left over. Or another way to say it is, think up here, 22 mod 7 is 3 1/7, that's where the 1 comes from. 7 over 8 is 0 with 7/8 left over. It's 0 plus 7/8. So that's why 7 mod 8 gets you 7 as a remainder. We'll talk a lot more about mod in the upcoming days, but just a little preview. You can think about, what if a number mod 2 equals 1? Well, that's a fancy way of saying when you divide the number by 2, the remainder is 1. We'll use an if statement like this to see if basically if num is an odd number. This if checks if num is an odd number, because when you mod a number by 2, if the remainder is 1, it must be odd. Similarly, look at an if statement like this, x mod y equals 0. You can think, what's the situation where x mod y equals 0? Well, it's sort of like this one up here, where 21 mod 7 was 0. So this is actually saying y is a factor of x, right? Or y divides evenly into x. We'll use mod in some clever ways to check for even odds and to check for sort of divisibility or factorness. And we'll probably end up using mod almost more than we'll use plain old integer division. Okay, that wraps up the last video, and thanks a lot. Bye-bye.